Hello, friends. Jim here. This headline that appeared in EOS, another record breaking year in the Arctic, amplifies calls for more data. A downward spiral of the Arctic's ecological health and climatic conditions continued in 2023, causing problems for people, plants, and animals, according to a new NOAA report. Okay, what's going on? All right, so they have here a green tundra with patches of snow. Alaska's Seward Peninsula is getting greener. Some reason it didn't want to load here, but I loaded it here. The image, that is. And first of all, the Seward Peninsula is that section, that part of Alaska that kind of looks like an arrowhead, whatever, that points westward into the Bering Sea, Bering Strait there. And so that's basically Arctic conditions here. And what we're seeing here, some snow, right? All these patches of snow. We see a meandering waterway here with lots of oxbows, right? And if you look, you see where these dark green patches are, where my cursor is trying to indicate. That's an example of the extent of the riparian zone. Riparian zones are associated with like rivers and lakes and so forth. And this is where we see typically larger vegetation growing. The reason for that being is that the water tends to, because of infiltrating into the ground table and so on, tends to prevent or minimize the expanse of permafrost. Thus, if the ground is not frozen, that allows deeper roots to take hold. And, for the plants that require deeper roots, they take hold and they grow. And that will include shrubs and trees and the like. Tundra plants, like what's out here, right? These are tundra plants out here. They don't need to have a deep root system. They can just anchor in the upper couple of inches, a few centimeters of the ground. So, but they're also limited in the size they can grow. So as I said, we see very nicely the riparian zone surrounding this meandering waterway here. Okay. Higher temperatures continued to destabilize the Arctic this year. Effects ranging from permafrost thaw to volatile weather conditions are causing further damage to ecosystems and human communities. Each year, scientists around the world, many of whom work and live in the Arctic, contribute to NOAA's annual report of the region's climate environmental systems. The Arctic Report Card 2023 provides an updated look at a region facing increasing snow and ice melt, volatile weather patterns, and unsettled ecological communities. Now, the Arctic Report Card, one of the editors on there is Rick Thoman. And you've heard me highlight some of his work and contributions numerous times before. He puts out basically a weekly newsletter. The Alaska. Hang on, trying to remember what it is. Let's see, but it's called the Alaska, Antarctica update. I'll put the exact wording in the comments section in this video. I strongly recommend subscribing to it. He presents a lot of the updated information, analyses, and so forth. And also, Sandy Shellis and Jennifer Hind over at Environmental Coffee House just last month, did a couple of videos, I think, on the Arctic report card. You might want to check those out. Everything just got a little bit more serious this year, said Paul Overdoen, a hydrochemist at the Alfred Wegener Institute for Polar and Marine Research and the lead author of the report's Undersea Permafrost chapter. The report documents a substantially changing Arctic, said Walter Meyer, a sea ice scientist at NSIDC in Boulder, Colorado. And he was the lead author of the report's Sea Ice chapter, and that's the National Snow Ice Data Center. Shifting conditions highlight the need for more data to better predict or ascertain how changes in the Arctic will reverberate around the world. So let's look at some of the vital signs. This year broke records once again in the Arctic. Summer temperatures were the warmest ever. Snow covered in the North American Arctic hit an all-time low for May. Multiple locations saw record-breaking heavy precipitation. Surface air temperatures year-round in the Arctic were the sixth warmest since 1900. Arctic sea ice cover this year continued its trend of below-average extent. Below average extent, sea ice cover. The past 17 September sea ice extents were the lowest 17 on record. Okay, let's repeat that. The past 17 September sea ice extents were the lowest 17 on record. 17 for 17. Now, granted, September is the oceanic summer, but still, this is extremely troubling because if it's so low, it's not going to really grow back as much, so the winter extent will be less. Low sea ice conditions and widespread thinner, younger sea ice seem to be a new normal in the Arctic. Well, we're losing the sea ice volume, we're losing the old sea ice, we're losing the multi-year sea ice. Okay, finally got it to open. So let's look at these diagrams. So we start out in the top left panel, autumn 2022. Then we move to winter. That probably is a typo. That probably should be 2022 as well. Then we look over to panel C, is spring 2023 and then summer 2023. So, here's Alaska. Here's the Eurasian side, Russia, Kamchatka Peninsula, right? So what do we see here? In the autumn of 2022, we see a warm Arctic basin. And that's reflected by, a low sea ice extent. There's increased heat flux from the ocean warming the atmosphere. A couple of cool spots like around the Canadian archipelago, but overall, the Arctic basin is warm. Up to some places almost 5 C warmer. And this is just surface air temperature. Those are anomalies. And those are anomalies compared to 1991 to 2020. So just a recent 30-year average, and we're already this much warmer in just a couple of years past this recent year average, 30-year average. Winter, we see kind of a cooling down in eastern Russia, Alaska, kind of warm. A little cooling down in the Hudson Bay area. Mid to southern Greenland was cooler. Northern Greenland, and then when we get towards, basically Nares Strait and into the Barents and Laptev Sea area, approaching Novaya Zemlya, we see some warming. Springtime. Alaska was a cool spot in the springtime. North America was warm. The Canadian Shield portion was warm. Overall, Arctic Ocean is a little cooler, but we have this warm pocket in eastern Russia and over towards Novaya Zemlya, Svalbard, right, Iceland, so on. Scandinavia was a little warmer, about 1°C warmer. And then look at summertime. The whole region is just warmer. Yeah, a couple cool spots like for the Labrador Current and over here, more near average. Just overall warming in the Arctic. So we already touched upon that the sea ice extents for the basically the last 17 years, but the 17 lowest. Talked about how we're losing the multi-year ice and the ice volume. Sea ice reduces heat transfer between the atmosphere and the ocean, so less of it can lead to further ocean warming and additional ice loss. Yeah, called less albedo. More open water is also allowing for a rougher sea. The ice protects the coast. You don't have the ice, you're going to have storms battering the crap out of the coastline. It's often leading to huge chunks of real estate dropping off into the ocean. So you get more room for waves to build up. Communities are getting flooded. And here's an example. This is Kotzebue, Alaska. Flooded after a storm in October 2022. Lack of sea ice makes coastal communities more vulnerable to the effects of storms and heavy rain. And beyond the ice-free period, changes in the ice mean Arctic communities have to be careful when traveling. The character of the ice is different and less safe, meaning it's more prone to breaking up. And if you're traveling when it's doing that, you're in a world of hurt. The Greenland Ice Sheet, second largest ice sheet on Earth, continued to lose mass. Greenland Summit Station, highest altitude research station in the Arctic, reached temperatures above freezing and experienced melt for just the 5th time in its 34-year history of observation. And this is total mass change. The Greenland Ice Sheet has been steadily losing mass for decades, as shown by this graph of its total mass change, basically determined via satellite gravimetry missions. GRACE, Gravity, Recovery, and Climate Experiment. And then GRACE FO, which is the follow-up. But as you can see here, we got some seasonal fluctuation. That is an unmistakable decrease. In fact, I bet you have an extremely high R-square for this. This is dramatic. Greenland's losing the ice. Warming air temperatures have contributed to an overall increase in precipitation in the Arctic. In 2023, the Arctic received its 6th highest precipitation levels on record. You'll see this here in interior Alaska. Interior Alaska historically has been classified as semi-arid. Not anymore. We get lots and lots of precipitation now. In the warmest parts of the Arctic, snowfall is turning to rain. When that rain falls on snow, it freezes, leaving a very thick icy crust that interferes with the grazing of ungulates like reindeer, caribou. Well, reindeer is just the tame version of caribou. Basically, caribou and musk oxen. And this is Mark Cerezi, who is the director of NSIDC and author on the report's precipitation chapter. The Arctic is already seeing an uptick in rain on snow events, and their frequency is likely to increase. Let me pause here for a moment. I have done videos discussing just this very issue. How, for example, the longer rainy season now means that you have rain falling to the ground, carrying its sensible heat with it. It is percolating through the ground, and because it's sensible heat and it's above freezing, it's helping to thaw/melt the permafrost, further emitting methane and CO2, and further increasing the thaw and melt rates of permafrost. This is a study done right here in Fairbanks. I also did another video where models are projecting that by the end of this century, snow? What's that? There probably will not be any snow falling in the Arctic at all. That's crazy. That leads to, of course, far less albedo, so more sunlight energy being absorbed, rapidly warming up things. And what does fall as rain quickly freezes, and you get that freezing rain, you get everything coated in ice, and that makes for very treacherous conditions. This winter thus far, we have not seen freezing rain. It's been all snow. I am not complaining. I prefer that. The last several winters before that, and going back almost 15, 20 years or so, pretty much we get a lot of freezing rain events in October and November. And let me tell you, you don't want to be driving in those conditions. You'd be better off just putting on your ice skates. Seriously, it just gets treacherous. So the Arctic is undergoing dramatic changes. The Arctic is the bellwether of the global climate system, Serezi said. Though the effects of climate change are more amplified near the poles, they also provide a warning signal to the rest of the world as to what's to come as the climate warms. And here's a quote. You've heard me say this. How many times? What happens in the Arctic will not stay in the Arctic. Right here. You've heard me say this numerous times. The effects of the Arctic's disordered vital signs have reverberated through local ecological and human communities as well. As the Arctic gets wetter and warmer, plant communities are shifting. Arctic tundra vegetation is growing more, and Arctic shrubification. I don't know why, but Monty Python's "What a shrubbery" just came flying into my brain from the Holy Grail. Okay. So this Arctic shrubification, an increase in the cover height and biomass of tundra shrubs at the expense of lichen and moss species, is changing the landscape. Average peak tundra greenness, a measure of overall vegetation, was the third highest in recorded history this year. And here's an example of shrubification. They grow taller, which means the permafrost is thawing, allowing for the deeper roots that these vegetation require to take hold. The farthest north vegetation is not going to have a place to go, so you're losing a whole group of plants, said Uma Bhatt, an atmospheric scientist at University of Alaska Fairbanks and an author of both the tundra greenness and surface air temperature chapters. Uma Bhatt is an excellent scientist, and she's just an absolute wonderful person. I worked with her for years. As more shrubs, willows, and alders move to higher latitude, they replace the other plant species that some animals, such as caribou, rely on for food. Caribou basically graze upon lichen. Salmon populations have responded to climate change with extreme population variability, said Eric Shern, a fisheries biologist at the University of Alaska Fairbanks IARC, International Arctic Research Center, my old stomping grounds, and lead author of the Alaska Salmon chapter. Chinook and chum salmon have hit extremely low population levels in the past few years because of heat waves. Sockeye salmon, on the other hand, have done well, taking advantage of warmer temperatures. They didn't say anything about coho or pink. Pink salmons are interesting. They have a 2-year cycle, so you actually have distinct populations. You have the odd year and the even year. So they're kind of their own thing there, and they don't really migrate far up rivers. So pink salmon, they're an important food source, don't get me wrong, but they're kind of an interesting little group there. Rural Yukon communities commonly hunt, fish, and gather their own food, and the recent decline in chum and Chinook salmon has been devastating. There have just been incredible effects on rural and indigenous communities. Chum salmon are important for feeding dog teams. If folks have dog teams out in the villages, they need a good chum run to feed their dogs. The Chinook is basically for human consumption. That's king salmon, basically. But chum is important to feed the dogs. If you don't have enough chum, the dogs are not going to get fed enough. For some of the authors, this year's report card shows a great need for more scientific inquiry into the Arctic's physical processes, impacts of climate change, and how to predict future effects on Arctic residents. The problem is that the changes that are unfolding are happening faster than our ability to quite understand them. We're frantically trying to keep up. How true. Permafrost beneath the ocean, for example, could drive ocean chemistry and global temperatures through the release of planet-warming gases, methane. And I've done videos on that. But there's not much data on how much of the Arctic's 2.5 million square kilometers, about 956,000 square miles, of undersea permafrost has thawed, whether there are gases trapped beneath the ocean, what that gas may be made of, and the climate consequences of those factors. Meyer said plenty of research gaps remain regarding the role of Arctic sea ice extent in regulating global temperatures, as well as how to best forecast ice cover. Excuse me. The report highlights the role of Indigenous communities in helping to answer scientific questions. For example, Inupiaq observers are documenting environmental change and the effects as part of the Alaska Arctic Observatory and Knowledge Hub. But just more science alone isn't going to cut it, Sharon said. Policymakers need to better consult the available science when making decisions. Yeah, good luck with that. Okay, scientists collect the data, we do our analyses, we present our findings, we make our recommendations. Unfortunately, unless we're an elected official, we don't get to make policy determinations, and we don't get to implement policies. We have to convince the politicians, who don't have a science background usually, to make correct and good policy decisions. Other authors call for faster action from policymakers to cut greenhouse gas emissions and fossil fuel use, major contributors to climate change. We need to galvanize the political will to make a change, Bott said. Good luck. So, the Arctic is undergoing drastic changes. And you've heard me throughout the years I've been doing this. I've shared with you videos documenting everything that's going on. The thawing permafrost, the loss of the sea ice, ocean heat, methane thawing, precipitation changes. I've discussed all of these aspects with you in numerous videos. And as you can see, I wasn't making this up. But the Arctic is undergoing significant, drastic changes that have major implications for the entire planet. And it is, to be blunt, very concerning. So there you have it. And thank you for your time. If you stuck around to the end of the video, thank you for watching. Be sure to give this a thumbs up, as it really helps the channel. And if you can, please support me either on Patreon and or buy me a coffee. Details in the description box below. Thank you.